Hey, Wheaton North, Mr. Yergel here. Let's talk about concentration, molarity, and dilutions. Here we have a 5 molar solution. So by the end of the video, you should be able to calculate molarity and calculate molarity or volume in a dilution situation. Well, I'll give you a formula that'll work with that, and we'll kind of talk through that. Let's first talk about what concentration is. We've talked about molarity before, and I want to be clear that it's referring to a concentration. Okay, so concentration would be a broad term. The molarity is the units, the specific units that we're using to talk about the concentration. So a concentrated solution has a lot of stuff dissolved. Think about Kool-Aid or Gatorade with a ton of powder dissolved and not very much water. Whereas a dilute solution would be the opposite. Lots of water and relatively little solute or salt or sugar or whatever is dissolved in it. Okay, so if you think about it from a particle picture perspective, a concentrated solution is going to have a lot of particles packed in there. You can almost say that its density is high, not in the sense that the density actually is high, but the particle density is high. There's lots of particles in a smaller amount of space, whereas a more dilute solution will have those particles of solute, salt or sugar or Gatorade powder, whatever it is, more spread out. They're spread throughout a larger volume of water, or there's just fewer of them, and so then they're spread out because of that. Here's a good particle picture. The dark circles, the bigger circles represent the solute, and I think they're using the smaller circles to represent a solvent, which in most cases is going to be water. Now let's talk about molarity. Concentration is described by the amount of solute per the amount of solvent. There's lots of different units for this. There's parts per million, there's percent by mass, percent by volume. The most common one that we're going to use is molarity, and it's the moles per liter. Okay, that's something you should just know. You probably know it already. Molarity is moles per liter. It's usually referred to or shown in terms of mol/L for moles per liter, but sometimes you'll see it like this, moles times liters with a negative exponent, which is really just the same thing. We often will just say big M. So if you're doing a calculation, the answer is just 5 with a big M. Means 5 molar. Okay. Remember that the solute goes into the solvent. So here's our unit, our units on our molarity. Because this is just something to keep in mind, you won't see this very often, but because volume is temperature dependent, meaning as the temperature changes, if you heat something up, the particles expand and it takes up more space. And so molarity can change slightly with temperature. So a lot of times we'll just say the molarity is at room temperature. All right, let's do a few examples. If we have 3 moles of sodium chloride dissolved in 6 liters of water, what's the molarity? This can be done without a calculator. 3 moles per 6 liters would be half of a mole for every liter. So 0.5 molar would be how you would say that. If you're given grams, then it's the same thing, but you just first have to convert it to moles. And so 58 is the molar mass, so 29 divided by 58 is a half a mole. Half a mole in 1 liter would also be 0.5 molar solution. A couple more examples. If we have 100 grams of potassium fluoride and it's dissolved in 300 milliliters of water, what is the molarity? Again, you're just converting to moles first, so 1.72 moles, and then putting that over your volume, which in this case is 0.3. Make sure you move the decimal, 0.3 liters, and so your final answer is 5.7 molar. Now this one's a little bit different. It's asking you to calculate the volume. It gives you the molarity. So you set it up the same way. The molarity is equal to moles over liters, and liters in this case is our x, and so then you're just solving for x, and you would need 1.8 liters. All right, so if we have 3.12 grams of hydrochloric acid, or HCl, in 250 milliliters of water, what's the molarity? Again, we need to convert to moles, and so that's what I'm showing right here. 3.12 grams times 1 over your molar mass is 0.0855 moles. And then in a quarter of a liter is going to be a molarity of 0.342. It says if we add 250 milliliters of water, how does the molarity change? Is it going to go up or down? It should go down because we're making it less concentrated by adding water. And it should go down by half because we're doubling the volume, so you're doubling your denominator, and so your overall volume is going to be cut in half. If you make some iced tea that's too concentrated, how would you make it less concentrated? It's pretty straightforward. You just add a little bit of water, right? This is known as dilution, and it's actually very common and very important because manufacturers will ship acids or solutions of some sort. A lot of times it's acids. in a very concentrated form because they don't want to ship like a 1,000 gallons of it. They'd rather ship a smaller volume of a more concentrated version. And so when we order that and we need to use it, we often need to dilute it down to a concentration that is usable for us. You also would need to know how to make a dilution if, let's say you're doing like a biology experiment and you need to test bacteria or some sort of organism in different salinity, different levels of salt water. You would need to dilute it to a very precise concentration so that you could actually see how the concentration of salt affects whatever organism you're looking at. There is a dilution formula. It's M1V1 equals M2V2. I hesitate to just give you the formula and it very quickly turns into plug and chug. I want you to understand what this actually means and how it actually works. This is a molarity, a concentration. So our initial concentration and our initial volume before diluting it is equal to our final molarity, or concentration, and our final volume multiplied. Now, if you think about the units here, this is moles per liter, and this is liters. If you multiply them, what are you left with? The number of moles. So what this is saying is the moles before you dilute something is the same as the moles after you dilute something. And that's actually why this formula works. So if you take a milliliter out of this stock solution, stock solutions are usually the concentrated solution. If you take a milliliter out, the moles that exist in this milliliter are going to be the same as the moles that exist in the entire diluted amount, right? And then this is called a serial dilution because we're diluting it over and over and over again. You take a sample out of that, the moles in this sample are going to be equal to the moles after you dilute it here, right? And so that's why we use this formula, and that's how it works. Let's run through a few quick examples. If you have 240 milliliters of a 3.5 molar solution and you're diluting it to 300 mils solution, so you're adding like 60 milliliters, calculate the new molarity. Figure out which one is our variable. The new molarity, that's going to be M2. And so we just kind of go ahead and plug these into the formula, and we're calculating how many moles we have here and then dividing by the volume essentially to figure out what our concentration is. Go ahead and pause the video and do this one on your own. You should have gotten 0.88 molar. Now this one's a little bit different. What volume of 9.3 molar H2SO4, that's sulfuric acid, is needed to obtain 450 milliliters of 2 molar sulfuric acid? So these are actually our final volumes and concentrations. This is after it's diluted. So it's asking how much of your more concentrated solution do you need to take out to dilute it to the 450. Still doing it the same way. We have our final molarity and our final volume, multiply those to figure out moles. And then we have our initial concentration, we don't have our initial volume. Solve for X, and you need 97 milliliters. So you would take 97 milliliters out of this, however much you have of this, and add water until you get to 450, and then you would know that your final concentration is 2 molar. What happens to the molarity when water is added? We've actually already talked about this in the iced tea example. The molarity would decrease. But what would you need to do in order to have the molarity increase? Think about your units. You would either have to decrease the amount of volume, which would be maybe by evaporating some of the water out, or you could increase the amount of solute. That would be just dumping more sugar or salt into your solution. So that's some basics on dilutions and molarity and concentration. Make sure if you have any questions, you write those down and bring those up in class. All right, this is Mr. Euler signing out.